Imagine one of the greatest minds in human history, someone who peered into black holes, decoded the origin of the universe, and spoke through a machine with words that echoed across science, politics, and philosophy. That man was Stephen Hawking, and before he passed away in 2018, he left behind a chilling warning. If humanity doesn't leave Earth, we are doomed. It wasn't science fiction. It was his final data-driven call to action. But why would one of the most brilliant cosmologists believe our planet is no longer safe for us? What did he know that the rest of us continue to ignore? Stephen Hawking believed in the power of science, but also in its responsibility. As he studied the laws of physics and the fabric of space-time, he began to realize that the biggest threats to humanity weren't distant asteroids or alien invasions, but ourselves. He spoke about it often in interviews, books, and public lectures. The extinction of the human species is not just possible, it's probable if we don't act. One of the first dangers he identified was climate change. According to Hawking, the Earth could become as inhospitable as Venus if carbon emissions continue unchecked. He warned that rising temperatures, melting ice caps, extreme weather, and collapsing ecosystems could set off irreversible feedback loops. The oceans would boil. The atmosphere would thicken with carbon dioxide. Life as we know it would end. And the planet wouldn't just get uncomfortable, it would become uninhabitable. But climate change wasn't his only concern. Hawking was deeply worried about artificial intelligence. Not the kind in smartphones or robots that clean your house, but the moment AI surpasses human intelligence, known as Artificial General Intelligence, AGI. He warned that once machines become smarter than us, they could develop goals misaligned with human survival. He compared the risk to unleashing a demon we can't control. The development of full artificial intelligence, he said, could spell the end of the human race. Then came biotechnology. Hawking feared that advances in genetic engineering, synthetic biology, and biohacking could be used not just for good, but for harm. A single individual could, in theory, engineer a supervirus capable of wiping out millions. Whether by accident or design, biological weapons could become tools of mass extinction in the hands of governments or rogue actors. He also pointed to nuclear war. Despite decades of disarmament talks, thousands of nuclear weapons remain on high alert around the world. A single mistake, a political miscalculation, or a cyber attack could trigger a chain reaction of global devastation. Hawking believed that the longer we stay confined to a single planet, the greater the odds that one of these catastrophic events would eventually occur. But Hawking's message wasn't just about doom. It was about urgency. He believed in the resilience of the human spirit and the potential of our species. But he argued that survival requires expansion, specifically into space. Colonizing other planets, he believed, is not a luxury, it's a necessity. Earth is fragile. It sits in a precarious balance, and we're pushing it closer to the edge every day. To ensure our survival, we need a plan B. And that plan B, in Hawking's mind, starts with Mars. He proposed that within the next 100 years, we should establish self-sustaining colonies beyond Earth. Mars was the first logical step, reachable with current technology and potentially habitable with the right infrastructure. But even Mars, he believed, was just the beginning. Long-term survival would require us to venture even farther, to moons like Europa, planets around other stars, maybe even other galaxies. The idea wasn't escapism, it was evolutionary necessity. Some critics called it unrealistic. They said we should fix Earth instead of fleeing it. But Hawking never proposed abandoning our planet. He advocated for both, protect Earth and prepare to leave it. He saw space not as a replacement, but as a backup, a safety net for our species in case the worst happens. And considering the risks he outlined, it wasn't a matter of if, but when. To many, his warnings sounded extreme, but time is proving him right. Global temperatures continue to rise. The Arctic is melting. Species are vanishing at rates faster than during any known mass extinction. Tensions between nuclear powers are escalating. AI is accelerating faster than regulators can comprehend. The threats he outlined are not abstract, they're headlines. And yet there's still time. Hawking believed in hope, in progress, in the brilliance of human ingenuity. He dedicated his life to understanding the universe, but in the end, his greatest concern was preserving humanity's place within it. He urged governments to invest in space technology, to support international cooperation on climate and AI safety, and to expand our collective vision beyond the confines of Earth. His final message wasn't one of fear. It was a challenge, a call to think bigger, to act faster, to imagine futures that don't end in catastrophe but in discovery. Hawking once said, "Remember to look up at the stars and not down at your feet." But now, perhaps more than ever, that's not just poetic, it's strategic. Our survival may depend on it. Stephen Hawking's vision of humanity as a multi-planetary species wasn't rooted in fantasy. It was grounded in hard science and the historical trajectory of human progress. Since the dawn of civilization, we've pushed past our limits, across oceans, over mountains, and into the skies. Space, in Hawking's view, is the next frontier in that evolution. But making that leap isn't just about rocket launches and spacesuits. It requires rethinking everything we know about survival, technology, and the nature of life itself. Let's start with Mars. It's the most Earth-like planet in our solar system, with a day just 40 minutes longer than ours, seasonal cycles, and frozen water at the poles. But Mars is no paradise. Its atmosphere is less than 1% the density of Earth's and composed mostly of carbon dioxide. Temperatures can plummet to -100 degrees Celsius. Radiation from the sun bombards the surface due to the lack of a protective magnetic field. To live on Mars, we'd need to bring our own habitats, sealed, pressurized, and shielded from cosmic rays. We'd need to grow food in artificial biospheres, extract water from ice or hydrate minerals, and generate oxygen through chemical or biological processes. It's not impossible, but it's incredibly difficult. Still, Hawking believed we must try. He wasn't alone. Private companies like SpaceX have taken up the challenge, with plans to send humans to Mars within the next decade. NASA's Artemis program aims to return to the moon as a stepping stone. China and other nations are also racing to establish a foothold in space. The idea isn't just exploration, it's colonization, not as conquerors but as caretakers of human continuity. Beyond Mars lie even greater possibilities and challenges. Moons like Europa and Enceladus may harbor subsurface oceans beneath icy crusts, warmed by tidal forces from their parent planets. These alien environments could be the best places to search for extraterrestrial life, and someday, perhaps, to build human outposts. But getting there requires technology we don't yet have. Interplanetary travel is hard enough. Interstellar journeys are a whole different scale. The nearest star system, Alpha Centauri, is over 4 light-years away. With current propulsion systems, that would take tens of thousands of years. Hawking, always ahead of his time, supported the breakthrough Starshot project, a plan to send tiny, light-propelled spacecraft to nearby stars at 20% the speed of light. The idea is radical. Use powerful lasers on Earth to push microscopic probes across space. If successful, it could change everything. Not just how we explore, but how we communicate, navigate, and perhaps even escape. But the journey isn't just physical. Colonizing space demands psychological, biological, and sociological resilience. What happens to the human mind in deep isolation, months or years from Earth, with no immediate return? How does our biology adapt to low gravity, high radiation, and confined environments? Can we build sustainable societies off Earth with justice, cooperation, and purpose? These aren't sci-fi questions, they're scientific imperatives. Because if we bring our same flaws into space, conflict, greed, short-sightedness, then escape is pointless. We need not just better rockets, but better reasoning. Hawking knew this. His vision was as philosophical as it was technological. Leaving Earth for him wasn't just about survival. It was about expansion, not of territory, but of consciousness. To see Earth from the outside, as astronauts do, is to grasp its fragility. The overview effect transforms people. It shrinks our egos. It makes borders seem petty. It reveals that we are one species on one tiny planet in a vast, silent cosmos. If more of us could experience that, even vicariously, we might treat each other and our world differently. But there's a paradox. The very technology that threatens our existence, AI, nuclear energy, genetic engineering, might also be the tools that save us. Artificial intelligence could help design closed-loop life support systems, optimize resource usage, or predict space weather. Nuclear power could provide compact, long-lasting energy sources for off-world colonies. Genetic editing might help us adapt to alien environments, resist radiation, or even terraform hostile worlds. In Hawking's view, the key isn't to fear technology, but to guide it, to align it with our values, our ethics, and our long-term survival. This is why he urged not just governments, but individuals to think cosmically. He wanted students to study physics, mathematics, and engineering. He wanted children to dream of the stars. He believed that curiosity, imagination, and collaboration are our greatest assets. In the 21st century, the greatest act of rebellion against extinction is education. And yet, even if we master space travel, solve the engineering, build the habitats, and launch the missions, what kind of life awaits us among the stars? Is it a life of isolation, struggle, and sacrifice? Or could it be one of wonder, creativity, and discovery? Hawking believed it could be both. That the hardship would be real, but the reward profound. A civilization that spans planets, that learns from its mistakes, that embraces science and humility, could become something truly extraordinary. Ultimately, Hawking's final warning wasn't just a prediction, it was a choice. We can stay on Earth, ignore the risks, and hope for the best. Or we can look up, rise to the challenge, and build a future among the stars. It's not easy. It may not be quick. But it is perhaps the most important journey we'll ever undertake. As we peer further into the cosmos, a fundamental truth emerges. Earth is not a permanent sanctuary. Even if we solve every human-made crisis, climate change, nuclear proliferation, AI regulation, the universe itself presents dangers we can't ignore. Asteroid impacts, solar flares, supervolcanic eruptions, and even the slow death of the sun are inevitable. The only true insurance policy for humanity is diversification, having branches of civilization beyond this single fragile sphere. Stephen Hawking wasn't sounding an alarm out of fear. He was offering a roadmap to survival. Yet for many, the idea of colonizing other planets still feels like science fiction. But consider this. A century ago, space travel itself was a fantasy. The notion of walking on the moon was laughable. Now, we have a continuous human presence aboard the International Space Station, private rockets returning to land vertically, and detailed maps of exoplanets orbiting distant stars. The pace of technological advancement is accelerating. What once took centuries now takes decades. If we commit to the goal, the leap from Earth to Mars could be followed by even greater cosmic strides. But survival isn't just about escaping extinction. It's also about thriving in new environments. To do that, we must redefine what it means to be human. Biology, as we know it, evolved under Earth conditions. 1G gravity, a nitrogen-oxygen atmosphere, a magnetic field, and 24-hour cycles. Remove those and our bodies begin to break down. Bones lose density. Muscles atrophy. The immune system weakens. Radiation damages DNA. To become interplanetary, we may need to become post-biological. This doesn't necessarily mean abandoning our humanity. It means enhancing it. Using biotechnology, we could engineer resistance to radiation, improve oxygen efficiency, or adapt to low-gravity conditions. With neural interfaces, we could maintain mental health in isolation. With AI companions, we could preserve culture, memory, and purpose, across generations of spacefarers. Hawking understood that the greatest journey isn't just spatial, it's evolutionary. The human species may not just migrate, it may transform. And what happens when we meet the unknown? The universe is vast. Hundreds of billions of galaxies, each with hundreds of billions of stars. Even if intelligent life is rare, the numbers suggest we're likely not alone. But if advanced civilizations are out there, where are they? This is the Fermi paradox. Perhaps they never made it past their own existential threats. Or maybe they're so advanced we can't even recognize their presence. Some might exist as digital minds, embedded in stellar structures or quantum networks. Others may have chosen to remain silent, observing, waiting. Hawking was cautious. He warned against broadcasting our existence too boldly. Just as early human tribes encountered danger when meeting others, announcing ourselves to the galaxy could invite threats. But he also believed in the possibility of peaceful contact and in our duty to explore, not just for curiosity but for connection. The act of reaching out, even into silence, is an affirmation of life. There's also the possibility that we are the first. That intelligent life is so rare that we are the pioneers, the species that breaks the silence, crosses the stars, and carries consciousness into the void. If that's true, the responsibility is immense. Our survival matters not just for us, but for all the unborn civilizations that might one day arise. By surviving, we ensure the story continues. That's why Hawking's final message resonates so deeply. He didn't deny the beauty of Earth. He loved it. He saw its wonders more clearly than most, perhaps because he understood how delicate it is. But he also knew that love requires action. If we cherish Earth, we must protect it. And if we cherish humanity, we must prepare for the long road ahead. Space colonization, then, isn't abandonment, it's expansion. It's not escapism, it's engagement with the deepest truths of existence. That life is fragile, that the universe is vast, and that the future is not guaranteed but built, step by step, mission by mission, idea by idea. In this light, Hawking's warning becomes a call to greatness. To embrace the unknown, not with fear, but with determination. To rise above the noise of daily crises and see the long arc of civilization. To choose science, cooperation, and courage over despair, division, and denial. We may not know exactly when we'll leave Earth or where we'll go first, but we know why. Because to do nothing is to accept extinction, and to act is to affirm life. So as we look to the stars, let us remember, the universe does not owe us a future, but we can create one through reason, through imagination, through resolve. And in doing so, we honor the legacy of minds like Stephen Hawking, not just with words, but with action. His chair may be empty, but his vision lives on, in every telescope pointed skyward, in every rover on a distant world, and in every person who dares to ask, what's next? The question we now face is not whether we can go, but how we will choose to go. The technology is progressing, the science is catching up, but our mindset, our cultural readiness lags behind. To truly become a spacefaring species, we need more than rockets. We need a shift in philosophy, a new narrative, one that reframes exploration not as a luxury or a race, but as a necessity for survival and a moral imperative for a thinking species. This means rethinking how we teach science, how we fund research, and how we inspire the next generation. It means moving beyond tribal politics and thinking globally, planetarily, because no nation owns the Earth and none will own the stars. The effort to expand humanity's footprint into space must be collaborative, not competitive. When the first settlers reach Mars or establish a permanent lunar base, their flags will matter less than their shared humanity. And that future is already taking shape. Private companies like SpaceX are reducing launch costs and planning missions to Mars. NASA and international partners are building the Artemis program to return humans to the Moon and eventually push further. China has a growing space presence. India, Japan, and Europe are expanding their programs. And while these may seem like separate efforts now, The complexity of living off-world will eventually demand cooperation. We'll need closed-loop life support systems, sustainable habitats, and local resource utilization. We'll need ways to grow food in harsh environments, generate energy from alien sunlight, and recycle every drop of water. These aren't just engineering problems, they're civilization problems. And solving them for space will help us solve them for Earth. The technologies developed for survival on Mars, like carbon recycling, solar efficiency, and climate control, could help us heal the damage we've done here. But the biggest challenge may be psychological. Can humans adapt to isolation, confinement, and the eerie silence of other worlds? Can we build communities without sunlight, forests, or oceans? Can we raise children under different skies and teach them to love a planet they've never known? These questions are not theoretical. They are real, and they are coming. That's why we must start now. Not just with rockets, but with stories, with art, education, and public engagement. We must imagine a future in which children dream of being space farmers, architects of orbital cities, philosophers of gravity, and poets of distant moons. We must cultivate not just the tools of survival, but the soul of exploration. Because when we step onto another world, we won't just carry our bodies. We'll carry our values, our histories, our fears, and our hopes. The stars will not change us. We will change ourselves in pursuit of them. Stephen Hawking understood this. That's why his warning was never just about catastrophe. It was about potential. He saw in the vastness of space not a void, but a canvas. He saw a future where human ingenuity could overcome any obstacle, if we were brave enough to try. His voice, once trapped by disease, traveled across time and space, urging us to lift our eyes. So now it's our turn to build the vessels, to chart the course, to ensure that our descendants look back not with regret, but with gratitude, that we didn't wait for disaster, but reached for the stars while there was still time. We are the transitional generation, born on one world, dreaming of others. Our choices will determine whether the light of consciousness spreads across the galaxy or flickers out in the dark. And in that decision lies the true meaning of Hawking's final warning. Because it wasn't really a warning, it was a challenge. And it's still echoing across labs, classrooms, launch pads, and perhaps one day, across worlds. What happens next is up to us.